We could describe how a sender is implemented using the unreliable send and receive operations, just as some code, and we could do the same for the receiver. But the problem with code is that it can have lots of details we don't really care about, like the precise structure of for loops or what kind of functions to write. So we're going to use a notation to describe the algorithms more generally for how a sender progresses through different decisions about using send and receive, and then how the receiver does the same on its side. And our mechanism that we're going to use to describe this more abstractly is called a state machine. State machines are not specific to networking. They're a general construct, a general way of describing the behavior of a system. And the way you do that is you say that a system has a given set of states. So here I've got three fixed states, state 1, state 2, and state 3. We represent the states by these blue circles. And then the thing that makes it a machine, and not just a set of states, is that a system can transition from one state to another when a certain condition happens. So we're going to draw arrows from one state to another, and we're going to write above that arrow, or near the arrow, but above a line here, a condition that says when the system transitions from this state to the other state. And then as it performs that transition, not only does it change states, it'll also perform some action along the way that we'll write below the line and in purple. So in general, we will have a set of states. There will be some lines between some of them, not necessarily all of them. Sometimes an action will go back to the same state. Each of these arrows has a condition when that arrow applies, when that transition applies. And when it does apply, it'll also do the actions as it performs that transition. So in this particular setup, if you start in state 1, you might stay there, but after you get out of state 1, there's no way to get back, it turns out. Once you get to state 2, you can go between state 2 and state 3, but not get back. And then you can see when you go from state 2 and what kind of actions happen. Let's try a more concrete example here. This is the classic vending machine example. Our vending machine has two states, one where it's waiting for a coin or waiting for more coins, and then a state where it's decided to give some food from the vending machine. It's waiting for that food to fall all the way out, and then it'll go back into the mode where it's waiting for some coins. This self edge here has a condition that a coin was added. So if we're waiting for a coin and a coin was added, we want to do something. We don't know what the person wants to order yet from the vending machine, but they added a coin, and so the amount of money goes back. So the action associated with adding a coin and staying in the wait for coin state is to increase the amount of money that we've recorded that has been deposited into the machine. If a button is pushed for some selection, and if the amount of money that's been added is at least as much as the cost of that selection, and as long as that selection is available, then our machine will go from wait for coin to waiting for vend. It will set money to 0 because now that money has been used up, and it'll start vending the selection. As soon as that selection has successfully come out, then the machine will keep the coins and go back to waiting for new coins. There's one more possibility, which is there's a coin return leveler on this machine. If the person using the machine pulls that, then drop out all the coins that we have. It could be 0 of them, but any that we have, and reset money back to 0. So this model of a vending machine leaves out a lot of detail, right? It doesn't say what's in the vending machine, or how much money each coin is, or what to do if the power cord is unplugged, right? It only says a few things about the machine that gets at the essence of how a vending machine works. And we're going to use this same idea to get at the essence of reliable data transfer.